Hi there, this is Mr. Alexander, and I'd like to talk to you about what we did in class on January the 7th and January the 8th. The 7.2 notes here, regression and polynomials. So what we've got is some data, and it's a table of values that shows the time of day and the average number of vehicles on a typical weekday. And what we want to do is we want to try and model this data as best as we can. So what you'll probably notice is we're supposed to describe any patterns, and what you'll notice about these patterns is the number of cars increases up until about 5 o'clock, and then it decreases. So I'm just going to write that. It increases until 5 o'clock, and then it decreases after that. And we're supposed to think about the sort of polynomial that best fits that kind of data. So when we're talking about polynomials, we're talking about things like linear functions, quadratic functions, cubic functions. Well, in my mind, the function that goes up and then comes back down potentially is the quadratic. But another one, if this is x squared, another one that could go up and then come down is x to the fourth, and we call that a quartic. And I'm not really sure which one it is, and part of my job today is to talk to you about which one it might be and how to make that decision. So I'm going to turn over the second page of these notes here, and we're supposed to create so we're going to make the scatter plot on the calculator, and I want to show you how to do that. What you'll need to do on this calculator is go to Stat, Edit. So I'm going to hit Stat, Edit, and I'm just going to type in the data that they gave me. I had data about 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, 5 o'clock, 6 o'clock, and 7 o'clock. And at 1 o'clock there are 7,000 cars on the road. At 2 o'clock there's 10.8 thousand, 14.5, 21.1, 23.9, 19, and 10. And I want to create a scatter plot. I can get the calculator to do that for me. If I go to second y equals, see this first stat plot here? That's off. If you hit enter twice, it'll turn it on. And then to get the calculator to go ahead and plot those points for you, you do zoom 9. So we've got some data here, and you can see how this maybe is quadratic. Maybe it's quartic too. I'm not sure. It's probably one or the other. But I can get the calculator to tell me the equation of a quadratic that goes through these points and of a quartic. Let me show you how to do that. If you go to Stat, Edit, Stat, and then over to Calc, if it's quadratic, we want to do Stat Calc 5 because that's quadratic regression. Let's just see what that spits out. It says y equals x squared plus bx plus c. It's giving you an equation here. And let's write down what that equation is. I'm going to write it under number 3 here. It's going to be y equals negative 1.364 x squared plus 12.157 x minus 6.157. Now, there's one other piece here that we're missing, and that's the strength of this equation. We can get the calculator to tell us the strength of this equation as well, but we have to tell it specifically how to do that. The first thing you want to do is go to the catalog, and that's second 0, and you want to scroll down after doing second 0 to diagnostic on. And once you turn on the diagnostic, enter, enter. Once you've turned on the diagnostic, go back to Stat Calc 5. And you'll notice that something's been added here, this r squared. I'm just going to write down that value really quick. R squared equals 0.83, and we'll round that up to 5. This was all for the quadratic. Well, that r squared is telling you the strength of the model. The closer this number is to 1, the better the equation fits the data. So 0.835 is actually pretty close to 1. I'm feeling pretty decent about that. But what we should do is graph it and see how it looks. So if we go to y equals and type in that equation, we've got negative 1.364 x squared plus 12.157x minus 6.157, and we graph that equation, you can see that it kind of goes through those points, but it doesn't seem to be a perfect fit. So we should check the quadratic regression as well. We should see if that's a good fit. And the way we do that is stat calc 7 and hit enter there. That's quadratic regression. And you'll see this is a big old nasty equation with 5 different numbers in it. I'm going to go ahead and write down those numbers here for the quadratic. It's going to be y equals 0.028 x to the 4th, because it's quadratic, minus 0.854 x to the 3rd, plus 5.925 x squared, minus 9.5x, plus 11.614. That's what the calculator told me. Now the calculator is also telling me one more thing, but I got to scroll down to get it. That r squared value. Notice how close to 1 it is. 0.985. I'm going to write that down. R squared equals 0.985. Just looking at that r squared value, you'd say this quadratic is actually the better model, because this one is closer to 1. That's close to 1, but this one's even closer. We should confirm it by graphing it. So I'm going to go back to y equals here, and I'm just going to type in that equation. I'm going to get rid of the quadratic one, and I'm going to type in the equation 0.028. I'm going to do x to the 4th minus 0.854 x to the 3rd plus 5.925 x squared minus 9.5x, and then plus 11.614. I'm going to go ahead and graph that. And look how good of a model this is. That thing goes through nearly every single point. This is the much better of the two models. This quadratic equation fits the data a lot better than the quadratic. And the reason for that is twofold. It goes through the points better, and the r squared value is closer to 1. So once you've got this model, you can answer some questions about the data. It says, use the regression equation that best models the data, which we decided was the quadratic, to make predictions. Downtown is congested when more than 20,000 cars are on the streets and highway. Predict when the downtown will be congested. So I've got this equation typed in here, right? That's my quadratic equation. If I want to predict when the downtown will be congested, meaning that there are more than 20,000 cars on the highway, well, I can just go look at my table, and I can see that between 4 and 5, that's when it's going to be congested, because that's when there's going to be more than 20,000 cars on the highway. So I'm going to write that. Between the hours of 4 o'clock and 5 o'clock. Oops. Period. All right. Well, in part B, it says predict the hours when the number of cars that enter and exit downtown is less than 10,000. Explain your reasoning. All right, so let's look at this thing, and I'm looking at the table. Looks like at 1 p.m. and 2 p.m., it's less than 10,000. So I'm going to write that. Between 1 o'clock and 2 o'clock. All right. Let's go down to part C here. Predict the number of vehicles that enter or exit downtown during the hours starting at noon. Okay, noon. So if 1 is 1 o'clock and 2 is 2 o'clock, 6 is 6 o'clock, noon must be 0. And it looks like there's about 11,614 cars on the highway based on this model at noon. So I'm going to write that, 11,614. Alright, here's where it starts getting a little goofy, and we're going to have a conversation to end this video in just a moment here. Predict the number of vehicles that enter or exit downtown during the hours starting at 9 p.m. Alright, well, 9, I'm going to scroll down to 9, and it looks like there's negative 32,000 cars. Well, let's write it down. Negative 32,819 cars. Don't forget your units on these. Well, that doesn't make a lot of sense yet. And I don't even know what a negative car looks like, but we'll talk about that in a second. Let's do part E real quick. Predict the number of cars that enter or exit downtown during the hours starting at midnight the previous evening. So midnight the previous evening. Okay, so if this is noon, then the previous evening should be negative 12. And there are 3 million cars at midnight. All right, well, let's just write it down. 3,035,100 cars. Now here's the conversation I want to have. I want to go way back here to the very front page, and I want to talk about this original data. Our original data was between, the original domain, I should say, is from 1 o'clock to 7 o'clock. Now, over here, when we're trying to make predictions, these predictions are well outside my domain, because this is 9 o'clock, which is outside the domain, and negative 12, which is outside the domain. When you're making predictions inside your data, that's interpolation. But if you're going to make predictions outside, that's called extrapolation. If you have a good model and you're making predictions using interpolation, you're going to have valid results. You're going to have answers that make sense. But when you start extrapolating, the further outside the domain you are, the less reliable the results are. So when we were talking about 9 o'clock, first off we talked about noon, which is pretty close to the domain. It's outside the domain, but the answer seemed reasonable. But when we started getting further away at 9 o'clock and midnight, those results didn't make sense. So you have to be very careful when you're extrapolating. If you don't have any information about the data, then your predictions may not make sense. And that's all I really want to talk about today. But let's just make a couple of notes about the important calculator things that we did. So remember, we're doing stat edit to type in data. To see the data, we're doing second, y equals, enter, enter, and then we're doing zoom 9. Zoom 9. So this sets the data in the calculator. This shows us the data. To get the equation, we're going to do stat, calc, and then we'll do 4 if it's linear. We'll do 5 if it's quadratic. We'll do 6 if it's cubic. We'll do 7 if it's quartic. And that'll give us the equation. And don't forget, another thing you need to do to analyze the equation to get the r squared, you need to go to second, 0, diagnostic on. If you don't turn on that diagnostic, then you will not be able to see the r squared value, and you won't know how good of an equation it is. Of course, you could graph it and see whether or not it's good, but you won't be able to assign a value to it to know exactly how good it is. If you don't have a calculator at home, I'm going to repost the link that I posted last semester on how to get a free calculator on your computer. So check out that video, and thanks for watching. Have a great day.